Welcome to the first video on the Tech Pro YouTube channel. This first video is entitled What is Power Factor? This video is being made to try to help some friends of mine who have been asking me about the new compact fluorescent light bulbs and the new federal requirement where you're not going to be able to buy standard incandescent 40 and 60 watt bulbs after the first year. They're going to be harder to find because they're not going to be legal to produce in the United States unless they're a heavy-duty industrial type bulb. So this video is to explain a little bit about power factor and hopefully try to get some information out there about what power factor is, why some people have been running into some issues with these compact fluorescents, and ways to work around that. So first thing we're going to dive into is how power is measured. We'll try to keep these slides fairly short. Just try to speak about this very briefly and try to give some real world practical examples about this. So power is primarily measured in watts and volt amps and these terms are often used interchangeably. A lot of people even consider them to be the same measurement. This is, however, very far from being true in practicality. It is true to some extent, but only with certain types of loads that you would use. And a load, as we're talking through this, would be any type of a device that's using electricity. It could be a transformer that you're plugging in to charge your cell phone, it could be a light bulb, it could be a TV, etc. So what we're talking about through this is real power. Real power is expressed in watts normally, and real power is you arrive at real power by taking the voltage and you multiply it by the current over time. So these are a few of the terms we're going to use throughout this short video. Real power is measured in watts and represents the actual work done by an electric current or the actual energy consumed by a load. Alright, so what does that mean? So understanding power factors, we'll give the electrician definition. A power factor by definition is a ratio of real power to apparent power. Okay, so some people are sitting there probably trying to figure out what that really means to a non-electrician, electrical engineer type person. The way that I understand power factor and the way that I try to explain it to people is power factor is a measure of how efficiently electrical power is consumed by a device, a light bulb, a heater, etc. So knowing that, you want to make sure you're using very efficient lighting, very efficient TVs, very efficient electrical devices, but understanding how power factor works will help you understand really how efficient that device is. There's a difference in using less real power and using less wattage. That's why we'll try to explain here. So power factor, the ideal power factor is what is more commonly referred to as unity, or the value of 1. Anything less than 1, and 1 is considered to be 100% efficient, meaning it takes the same amount of volt amps and watts to power the device, which means it uses the exact same amount of power to arrive at the wattage that it's rated for. And I'll explain a little bit more about that here in a demonstration. So anything less than 1 means that extra power is required to achieve the task, be it power a light bulb or a TV. So some of you might be sitting there thinking, well, if it says it uses 100 watts, it should really be taking 100 watts to power it. And if it's drawing 100 watts, it's really drawing 100 watts by the amount of current that's flowing to the device. And current is the important aspect in this. You can have a device that's rated at 100 watts and it actually take twice the current to power 100 watt load over another 100 watt load. So the first example that we use to try to explain that is a 60 watt light bulb. Um, we're going to make a few assumptions here, and these are fairly safe assumptions as long as you're living in the United States. I'm assuming that everybody watching this has a 120 volt service in their house. Over in Europe and certain countries they use 240. Same philosophy. It's just different ways to look at it. We use 120 volt, 240 volt main in residential here. 240 volt service is essentially just two 120 legs with a common neutral. Over in Europe, they use a 240 volt to the appliance as opposed to 120, and a lot of European services are 50 hertz as opposed to 60 hertz. That's why if you go overseas, you'll notice the TVs are a lot dimmer. The refresh rate on the devices over there is different than it is in the United States. That's a different topic for a different video. So we're looking at an incandescent light bulb. We're using a 60 watt light bulb as an example. So what I've tried to lay out here is how that falls into play for a 60 watt light bulb. If the light bulb is rated for 60 watts, it's going to draw 60 volt amps. And a regular incandescent light bulb's power factor is exactly 1. It's a purely resistive load. An incandescent light bulb is much like a heater that you'd plug in. It's passing power across a filament or a heating element, and it's called a resistive load, meaning it uses all the power very efficiently in that load to get the desired output, be it lumens for light or BTUs for heat. 1500 watt heater is going to draw 1500 watts, and it's usually, if it's a decent heater, it'll have a power factor of 1. And I'm going to have some videos on heaters showing the different types, showing the power factors, their ratings, etc. So if anybody would like to view one of those, they'll be posted online very shortly. So a standard light bulb has a power factor of 1. In this instance, very simple math. A 60 watt light bulb will draw 0.5 amps of real power. So if you think back a few slides, I said real power is classified in wattage. So it takes 0.5 amps of power to arrive at 60 watts of usage to light this light bulb. Incandescent light bulb and a heater, as far as power factor goes, is what would be considered a perfectly efficient device, meaning it doesn't take more power in terms of amperage and volt amps to arrive at that 60 watt rating. It's essentially efficient. It's going to draw the same amount of amps no matter how you do it. From that standpoint, incandescent light bulbs were very easy to figure out what the power draw would be on a breaker box in a house and how much power they would consume. Because if you had 10 60 watt light bulbs, you're drawing 600 watts of electric. It's very easy to do the math on that, and they would draw 5 amps of power. So the next type of light bulb we're going to compare this to is a CFL. I know a lot of people may be using these. They're very popular. This is what everybody's electric company is recommending. It's what is very widely available at any of your big box stores. If you walk in, they all have racks saying, your power company recommends using this type of bulb. A lot of them even give discounts to buy CFL light bulbs. There's going to be another very interesting video I would urge everybody to watch. There's some very disturbing and good information out on the net right now in regard to CFL light bulbs. I used these for a good number of years. I can say that I no longer have any of these in my house. I'd be more than happy to explain why that is, and I'm going to do so in another video that I'll probably have posted this weekend, explaining more about that. Some of it revolves around what I'm going to go over here in just a minute, but I do emphasize anybody that's entertaining the thought of using a CFL light bulb in their house to watch my other video or do some more research on your own. It explains a lot about this. in addition to what this power factor video has to talk about. So a CFL light bulb, a 60 watt equivalent, we're trying to do pretty light bulbs here, is rated at 13 watts. So you're going to see a package that says 60 watt replacement. It's going to look like this. Some of them have solid globes over them. They make them look different ways, but they're, at the end of the day, they're all the same type of bulb. They're all a compact fluorescent bulb, normally an instant on built-in ballast bulb, rated at 13 or 14 watts. So we're going to make the same assumptions that you have 120 volt service. This bulb on the package says 13 watts. If anybody notices out to the right, the volt amps on this bulb are 26 volt amps. So if anybody's sitting there wondering why the volt amps is almost exactly double what the wattage rating is for this bulb, whereas on the incandescent bulb, that was not the case. I'm going to explain that to you. So a light bulb was a resistive load. A compact fluorescent light bulb is different than a resistive load because it has a transformer inside and a ballast that starts this light bulb up. Fluorescent lighting is much different than incandescent. That could be a whole nother topic in and of itself, so that everybody would understand how a fluorescent bulb works. Essentially, it uses the energy to excite the material in the bulb, and that's why it puts off light. Whereas in a incandescent bulb, you're superheating a filament that's emitting light as the filament is essentially burning, but it doesn't actually burn up. It just gets white hot and puts off light. So these are much less efficient than a fluorescent or a incandescent bulb. Power factor on these bulbs, and I have tested these on my bench meters. I've seen everything from 0.20. Very, very, very cheap CFL has a very poor power factor. So these are not going to be the right measurements for every bulb that you may find. And I have seen on very good CFLs, a power factor of 0.65, 0.7, and there's ways that they can improve the power factor in these bulbs to make them use less amps to light the bulb, usually with capacitors. So this bulb will draw 0.22 amps of real power. I put on here it's half as efficient as it is rated on the packaging. So why is that important? The biggest reason why some people have maybe run into issues with this, and the reason why I had a few people asking me about these bulbs, is people are taking lights that may be rated for 40 watts, and logically they're saying, well, my light fixture is rated for 40 watts. I'd like my light fixture to be a little brighter than it ever was before. I'm using these looks to be super efficient bulbs that only are drawing 13 or 20 or 26, 28 watts. In their brain, a lot of people are saying it's drawing less power. If it's a newer light, and a lot of the newer lights have been required to be marked like this, you'll notice that the inside of the light will be marked with a 40 watt bulb or a 7 or 9 watt CFL rated light bulb. The reason they're doing that is because people don't understand what the power draw is actually of the CFLs. Just because they're rated at a lower wattage does not mean they draw less current all the time. So people are buying these light fixtures, putting much larger CFLs in them than they're really designed to handle the internal wiring. Because you could have a 23 watt CFL, its actual volt amps will be more along the lines of 46 or so, depending on how good or how bad the power factor is, and it will actually draw more power. And keeping in mind, it says it's still rated at 23 watts, but the cable that it's plugged into the wall with is pulling more amps than it would have pulled with a 40 watt incandescent bulb. And that's the important part to understand here. Just because its watt rating is low does not mean that's all the power it uses. So I just want everybody to try to keep that in mind. And the reason why that's important, if you put a bunch of these bulbs on a circuit that may be rated for a specific rating, an extension cord or of the like. All of these cables are rated for handling a specific amount of wattage or amperage. In an incandescent world, it's very easy to figure out what the wattage and amperage could be. The wattage and voltamps are the same, so a specific amount of wattage would always equal a specific amount of amps. In the CFL world, you could have 1,000 watts of CFL versus 1,000 watts of compact fluorescent or incandescent, and the CFLs are actually going to draw twice as much amperage as the incandescents do. You would have more light from the CFLs, but at the same time, they'd also draw twice as many amps. And that's because their power factor is essentially half that of the incandescent, meaning whatever the wattage is for the CFL, it's going to draw twice as many voltamps. And at the end of the day, how many amps are being sent down the wire to the load, in this case the light bulb, that's what's important. That's why your extension cords could get hotter than they would normally. And a lot of these bulbs, the power factor is just terrible. I hope this is helpful to some people. I hope it helps you think about these factors while entertaining what light bulbs to use in your house. I highly recommend everybody to watch my other video on light bulbs. I'm going to be comparing CFLs with LEDs. As I mentioned earlier in the video, I have no CFLs inside of my house. I do still use them outside of my house. If you watch my other video, I will explain to you why that is the case. It's not just because of the mercury that people say are in them, and that's that's a debatable topic. Mercury is not healthy for someone to breathe any way you look at it, but that's not the only reason. There's much worse reasons not to use them inside the house, in addition to the fact that they're not very efficient. The other thing that I will say, the reason why power factor is important to me, and maybe to other people, we lose power a lot. We live outside of a city. We're in a rural area, and we do lose power a lot. We do run on a generator and solar panels often. And having a section of loads in your house that have poor power factors calls your generator, because you're actually having to draw twice the power to light this 13-watt load as you would if it was just a purely 13-watt load. It costs more gas in the generator. You have less things on the generator because of this. And at the end of the day, the easy way to look at this is, if you have a device that has a power factor of 0.5, it takes twice as much power from your power company or wherever you're getting your power from to power that device, based on what its rating on the package is. 13-watt light bulb takes twice the power coming down your line to light that 13 watts. Your power company is only seeing you use 13 watts, so your power bill is still cheap, but it actually is taking twice the power to power it. And the last thing I'll say on closing, businesses' power is rated differently based on the power factor of the business's power draw. The power demand in a business is much higher than a residence. They're not billed normally the exact same way as a resident. And I will say it is awful odd when you walk in Walmart or Lowe's or Home Depot, any of your big box stores, and look at the light bulb shelves. The only place you see your power company recommending you go is to CFLs. And it's interesting that they're recommending a bulb that has a poor power factor, and at the end of the day it's going to cost them twice the power that you're paying for. You'll notice that they don't have any LEDs recommended. None of them are recommending LED light bulbs, when in fact they are usually a very high rated power factor, drawing 13 watts, normally 13 volt amps. I just kind of wonder at what point, with everybody swapping these light bulbs out, that your power companies are all going to come back to you and say, you're buying 1,000 kilowatts from me. You're only paying for 1,000 kilowatts. but it's actually taken me twice as much money to provide that 1,000 kilowatts to you, and we're either going to have to charge you because your power factor is bad, like we do businesses, or I'm going to have to significantly increase your um, electric bill because you're actually requiring more amperage from me and you're paying me less money because that's the way all of our meters are rated. It's just something to think about. I'm not saying that's going to happen tomorrow. I wouldn't be surprised if it happens soon, though. There'll be more videos up soon. I hope this is helpful to somebody. If anybody has any comments or questions, please feel free to um, send me a comment, send me a message. I'd be more than happy to reply back to you with any information I can provide. Thank you and have a good day.